We've already looked at scale factor of enlargement and reduction for lengths, and now we'll have a look at area and how the area scale factor differs from our length scale factor. So what I've got here is down one side an original rectangle, which I've done three different things to. So I've enlarged it by a scale factor each time, and we're going to have a look at what the enlargement scale factor for length and area is for each one. So we'll start up with this one up here. And again, when we're looking for enlargement scale factors for length, we're looking to compare corresponding sides. So say for instance the 3 and the 6 that I've highlighted there. So my enlargement scale factor for length is going to be a fraction 6 over 3. Because it's enlargement, it's going to be top heavy using those two numbers, and that will simplify down to 2. So my enlargement scale factor for length there will be 2. If I look at the area, and I can quickly write in the areas for these, that small rectangle has an area of 6 square centimetres, and the larger one is 6 by 4, so 6 times 4 is 24 square centimetres. If I want to look at the enlargement scale factor for area, then I'm comparing this 6 and this 24. Now again, it's an enlargement factor, so using the 24 and the 6 to make a fraction, we're going to end up with 24 over 6, which simplifies down to 4. And we're going to be paying attention to these two numbers once we've done the others as well. So we'll do the same for the other few rectangles down here. Again, comparing as we go, looking at the second set, we've got our 3 and our 9 here. So if I want to fill in my enlargement scale factor for length, I'm using the 9 and 3 to create a fraction greater than 1, so that's going to be 9 over 3, which is 3. Makes sense, those lines are becoming 3 times as big. And then for area, again, it's going to be exactly the same for this first one. It's going to be 6 square centimetres. The second rectangle, the larger one here, is 9 times 6 for its dimensions, so it's going to be 54 square centimetres. Using those two numbers, in other words, using my 6 here and my 54 here, comparing those two areas, again looking for the enlargement factor for the areas, I'm going to put the larger number at the top, smaller number at the bottom, and that's going to give me an enlargement scale factor of 54 over 6. Now that will simplify down to 9. And again, I'm paying attention to these two numbers here because I want to have a look at them later on. And very quickly we'll do the last one. So I've got 6 square centimetres here, and the larger rectangle is 12 by 8, so that's going to give me 96 square centimetres here. Again, if we're looking at comparing our lengths, we've got our 3 and our 12, which we can make a scale factor for length, comparing the lengths. So again, we can put 12 over 3, which simplifies to 4, which makes sense. That length is 4 times bigger. And then for the area, we're going to look at comparing our area of 6 square centimetres to our 96 square centimetres. And again, creating an enlargement scale factor for area, if it's an enlargement, it needs to be greater than 1, so big number over small number. It's 96 over 6, which simplifies to 16. So what we now have, as we look down the side, we have the enlargement scale factor for length and the enlargement scale factor for area, and we have it for each of these three enlargements that we've done. What we really want to do is see if we can spot what the relationship between the enlargement scale factor for length is and the enlargement scale factor for area. So we're looking for the relationship here between the number 2 and 4, the relationship between the number 3 and 9, and the relationship between the number 4 and 16. And hopefully what you might pick up there is that 2 squared is 4, 3 squared is 9, and 4 squared is 16. So if I want to find my enlargement scale factor for area, all I need to do is work out my enlargement scale factor for length, which we already know how to do, and then I can simply square it. I don't need to actually draw out these rectangles to do that. We'll now go on to the type of question we'll be asked to do more than likely in an exam. We need to be able to either enlarge or reduce an area, and to do that we have to square the linear scale factor or the scale factor for length. So questions like this will come up where you've got two paintings which are mathematically similar, It will give you maybe some lengths on the sides of the shape, which are corresponding to each other, and then it will probably tell you the area of one of the two shapes. So in this case, the smaller painting has an area of 1,200. So this one here, 1,200 square centimetres. And we are asked to calculate the area of the large painting. So what I need to do is basically take this number here, the area of the small painting, and multiply it by an enlargement scale factor for area. Now, first of all, to get the enlargement scale factor for area, we need to find the enlargement scale factor for length, because the information we're given on these two shapes that correspond to each other, these are lengths. So we'll start by highlighting the two of these. These are the lengths which we'll use to find our enlargement scale factor for length. So we'll write that out. Enlargement scale factor for length. And again, it's an enlargement scale factor here. We're looking, because remember what we have is, we have the area of the smaller painting. We're looking to enlarge this to find the area of the larger painting. Now, if we look at the two dimensions, our two lengths here, we have 70 and 50. And because it's an enlargement, we need a number bigger than 1, so 70 over 50. Again, I'm just going to leave it like that. In a non-calculator paper, I might simplify that, but there's absolutely no need to do that when you have a calculator that's going to do most of the work here for you. Now, I can't just multiply this 1,200, which is an area, by an enlargement scale factor for length. I need to actually multiply this area by an enlargement scale factor for area. So I'm going to write another line of working underneath. So enlargement scale factor, but this time this is the area scale factor. And what we've got up here, remember, to enlarge or reduce an area, we must square the linear scale factor. So if this is our scale factor for length, then our scale factor for area is simply that squared, and it is that easy. We're just going to put 70 over 50 in brackets, close the bracket and put a squared sign outside it. What we then do is, for the last part, we can just write the area of larger painting and all I'm going to do here is take my area of the small painting and multiply it by the enlargement scale factor for areas. So that's going to be equal to the 1,200, the area of the smaller painting, multiplied by the enlargement scale factor for areas, which is our 70 over 50 all squared. And we type that into our calculator exactly as it's written out there, making sure we have brackets around that fraction when we type it in. And that comes to 2,352 square centimetres. So just a quick recap. In these questions where we're asked to enlarge or reduce an area, we simply take our lengths, use them to, as normal, write down our enlargement scale factor for length. We then take the enlargement scale factor for length and we square it to get our enlargement scale factor for area, and then we simply multiply the area we want to enlarge by this. Now, bear in mind, this question can also be asked as a reduction, so just be careful at the very start to work out whether you're doing an enlargement or a reduction. I suppose that's the first place in a question you can go wrong, so just make sure you're thinking about what are you actually wanting to do with this number. Am I trying to make it bigger or smaller? And that should help you get these fractions the right way around.